Hello. So I'm actually just going to back up and do another video over how to set up the Tumblebug activity to give you a little bit of background on that. And then you can watch this second video in which it shows you the data that the students actually ran and their PowerPoint. So first off, I just want to show you when I'm talking about the Buggy that we use, this is it. This is on Amazon. It is called just a Tumble Buggy. It has gone up a little bit in price. You might can find it somewhere else, or actually you can find or use any kind of battery operated car for it. The only thing that I would say that I have found as a problem with some of the Walmart or Target cars, one, sometimes they go too fast, where this is a very slow moving buggy. The other thing is that some of the ones that you buy have, bells and whistles on them. They'll have fire engines or sirens or something like that, which makes it a little bit distracting and noisy out in the hallway. So this is my favorite, but like I said, you can use whatever you want to. So let me just show you how we set this up. Okay, so the first thing that I have the students do is go out into the hallway, and I have them draw for me on the ground and label every meter. Now when they're marking this off, how far you go is up to you on that. Basically, it may depend upon your buggy. If your buggy goes really crooked after 4 or 5 meters, then maybe 4 or 5 is all you can do. If your buggy is really good and will go 8 meters fairly straight down the hallway, then I would definitely go every 8. Now the other thing, once you have them marked off, you can either do one of two things, and I've done it both ways. Sometimes it's a good talking point to the kids. So you can either start the buggy at the 0 mark, or if you want, you can have them mark off back behind maybe another meter and actually start at a meter before the 0. And then that way when it hits the 0, they're all ready to start measuring. Now what's going to happen next is you're going to have however many students you have marks. So if I have 5, let's just say I'm going to have a student stand at the 1 meter mark. And so this student will time from 0 to 1. I'm going to have a student stand at the 2 meter, and he'll time from 0 to 2, and so forth. Someone at 3, 0 to 3, so forth. Make sure you have those who are fairly good at the timing, be it the 1 and 2, just because those do go fairly quickly. So this is kind of the setup. So you have your car, and again, you're just timing it. And then you're just going to fill out your data table on that. Now I have the students always run it 3 times. So we'll run, every person will get 3 readings, and then we always do an average. Now, when you get done with your recording of your data, then that's when I go to my graph paper, and we want to do it as a distance time graph. In other words, we're going to relate our distance to our y value and our time to our x value. That's why when we do our slope, we have distance over time, and so the slope of our line will be the rate. Okay, so then this will be what the data will look like when the kids are done. So here's my distance 1 to 8. Here are my 3 trials, and then the average of each. Now from there, and I'll show you, you can actually do this several different ways. You can either have the students by hand do your distance over time and plot your points, or if you want to worry more about the analysis part of it, then I would have them put it into either a graphing calculator or the Desmos app. Now my students put it into the Desmos app, so that's what you're seeing here where they're getting their values. Okay, so again, here is the graph of their data. And you can have them play around if they want to a little bit with the X and Y axis and determine what's the best on that scale to use. So then we can talk about what's happening here. Obviously this is pretty much a straight line. Therefore, we're proving that our buggy is constant motion. So now we can do slope, distance over time, and find exactly how fast the buggies go. Now what I have my students do is each one, if they're using, like I said, I have about 5 cars, so if each one is using a different buggy, I usually try to put them in places where they actually can't run the buggies beside each other before we're done. And so then after they've done all of their analysis and they each know how fast their cars are going, then I say, okay, if that is true, who would be the fastest? If we were running a race, who would win and who would lose? And so then they line up the cars, their information, and they do a prediction of who would win and who would lose. And here's what I do next. After we're done with that, is I tell them, okay, if instead of putting the cars side by side and running them to see who wins, what happens if we just did the opposite? What if I put one, and I think I told them here at 12 meters. So if the cars are 12 meters apart, so in other words, we mark off now 12 meters on the hallway, and we start one car at 0 and one at 12, and we turn them to face each other. Okay, and I want to know, where do they predict they're going to cross? And now we've got to look at the fact that one of our cars, whichever one, and I tell them it's up to them to decide, but as a group they kind of have to decide. So this one starts at 0 and it's going towards, so we're going to call that a positive, because our direction would be in the positive. So now you can even talk a little bit about that sometimes when we get into, especially when we get into physics and so forth, that a negative slope does not mean it is going slower necessarily, but it could mean direction. Okay, and so then that's what we talk about here. So this one starts at 12 and it's going in a negative direction compared to this one. So this would be our positive direction, 0 and going in a positive direction. This would start at 12 and go in a negative direction. And so then we've kind of tweaked things around a little bit and making them have to think about what is taking place. And then where is it going to meet? And so once they find their meeting spot here, so then they have to think, okay, from, which buggy, again, they've got 2 buggies running. They've got to keep track of which buggy's which. So if I start the blue buggy here, then the blue buggy at this time of marking will be here, and I think this goes by 2, so 2, 4, 6, so it will be 6 meters down the road and take how long? Now these were, and some of them, one will definitely go faster than the other, and so this is not set exactly at 6 on that. And then the red buggy, and where will they meet? And so then they mark on the ground the meeting spot, and I think that's in the next video where I show you that. And then we actually run them and see. And some of them are almost perfect where they do meet exactly where the kids tell you. I videoed that piece and I like to do it in slow-mo on that so that the kids can really see what's going on. Okay, so the next thing that we do, and I will say that this is a several day activity, but I feel like it really does cover a lot of stuff. So the next day what we do is we take our data table that we had earlier and we record our distances and we record our average time. Okay, and then we talk about what velocity is. Okay, so velocity, again, distance divided by time. And what we now do is we find the velocity at each interval. Okay, each interval. So instead of looking at the slope as a complete line, we're going to look at it at each interval. So in other words, going from 0 to 1, how fast was it? Going from 0 to 2, how fast was it? Going from 0 to 3, how fast was it? And so forth. And then we're going to plot that on here. So what this shows the kids then is that, and I love this because what they'll see real quick, and they can kind of see it from up here. I'm not sure, they've got 2, that almost look like a negative, but they put 2 decimal points on there. So what they're going to see here is, which is acceleration, and the fact that that buggy had no acceleration. Okay? 0 slope, no acceleration. And for some of them, it does really start clicking because you start seeing, okay, here is my linear, my line, in which it has a constant velocity. Okay, so that I could find just the slope of that line. And then when you put it onto a velocity time graph, now the other was a distance time graph, when you put it onto a velocity time graph, how it also shows you that your acceleration was 0. Okay, so I think it's pretty fun. It's like you'll really be amazed because I have kids who are very low math skills, but when they put it on the graph and then they look at the buggy and what happened on the buggy, and again refer back to the buggy. Now look, this is what was happening to the buggy, and then look at the graph. Then it starts clicking with them. Okay, so here is the second piece of my graph, and what we do here is we take and I build a ramp, and you can build a ramp out of about anything that you want. I have kind of a 2x4 or a 1x, I guess it's a 1x4 ramp that I do. I've seen people who have done it with PVC pipe cut in half. I usually try to make mine about 3 meters on there. And so when I do it, this one, I do it by halves, okay? 0.5, 1, so forth on there so that they get enough readings. So we take the ramp. You can decide what angle you want it on. And sometimes I'll play with it ahead of time just to kind of see. If you were doing it with PVC pipe cut in half, I would say probably use a marble on that, maybe a large marble of some kind. If you're doing it on a ramp, then what I use is Hot Wheel cars. Okay, and the kids love that. And if you're having them do different ones, they can pick their car and so forth. So all we do again is we mark it off just like what we did before. And this time, again, I have the kids record it. This one goes really fast. So as you see here on our time scale, this is only a matter of 2 seconds. Okay, here's our seconds. So what I actually have the kids do on this one is I have them take their phone and put it in slow-mo. Okay, and then that way on there, they can, if they all start at the same, then they can use their finger to take their slow-mo, okay, and find, you know, they'll cursor, they'll scroll over until their car is on the mark. Make sure the mark is where it's readable. So they're actually going to be filming the track more so this time than before. So they're going to want their phone picture on the track where the mark is at. So as soon as that marble, they're going to have it tipped so they can see the marble or the car or whatever. They need to see both of it. So that on their camera then, when they scroll, they see that when the car actually is at that mark. And again, then they can just read the time that's on there. Okay? And again, I do have it set up the same way as before. So the first person will read from 0 to 0.5, 0 to 1, 0 to 1.5, and so forth. Okay? So basically the same setup. The difference is in the reading of it, I have them do it on slow-mo. Because if not, it will go so fast, they're not that fast of reaction time on them to turn their timer off. Now, I've done it before where I've used bigger things and a very small incline and, you know, did it that way. So here is, again, the graph. We do the same thing. This is just our average, okay, our average time. So distance over time graph. Here it is. And you do sometimes have to fudge a little bit with it for them to see that this should be a parabola, okay, because our car is accelerating on that. Sometimes their data will work very good on that. And of course, sometimes also the longer you can make your ramp, the better the data goes, that it'll come up. Also, according to how much they zoom in or out will affect what their data looks like. Okay. Then again, we do the same thing with velocity and time. So we graph the velocity against the time on there, and native on that. Change the angle of your ramp. Okay. I think that's an awesome thing to do as an extension of that is, or even if you're doing multiple groups, have one do it at one angle, another at an angle, and the steeper the angle, the closer that, and now this will actually gravity. So you can kind of look at that piece of it, but it will, again, if they do different angles, then what you're going to see then, of course, is your parabola being steeper and steeper on that. So then that becomes another talking point on there. Anyway, this is my buggy activity. Buggies. This is where they're racing them. As you can see, that front one there is one of the Walmart cars that I bought. It is a little harder to control.